Hello all my P1 students, welcome to Deeksha Karnataka YouTube channel, and today for all of you I am bringing the passing package so that if you have not studied anything and you are wondering, sir, I just want to pass in physics, then don't worry, I will help you to get at least 45 to 50 marks. So if you watch this video properly and then if you practice these questions and answer, obviously not only questions, you have to practice the answers as well. So if you do that, then definitely you are secure to get at least 45 to 50 marks. All the questions that I am going to discuss are very important. So how will be the lecture today? So I will start with MCQ questions. Once MCQs are done, we will be solving 2-3 marker questions as a bunch, because some questions, some 2 marker questions can also be asked as a 3 marker question. Some 3 marker question can also be asked as a 2 marker question. So we will discuss 2-3 marker questions and then we will discuss some very important derivations as well. And if you want to study more questions, definitely we have done a long videos of all MCQs, all 2-3 markers and all 5 markers. You can go and check that out. Today I am not going to solve any numerical question because this is a passing package and this meant to be someone who are slightly weaker in mathematics. So if you are want to revise some questions, if you want to practice more questions, definitely you can check my long form videos as well. Now yes, Divine, hi, good afternoon. Harshvardhan, good afternoon. So I hope you all are doing well, right? So as I mentioned, today I am be discussing mainly all the questions which are important, very specific important questions for your PU2. So you should not skip. Even if you have watched the previous videos, you should watch this video because these are the most important questions. These questions will I am expecting at least 80% of the questions will come in your PU1, right? Hello. So let's start. So we will, if you are willing, I am giving you MCQ questions. You should answer them in the question by mentioning question 1, option A. So 1A, 1B, 1C, like that you can answer the MCQ questions along with me. So that will be a practice for you as well. Which of the following statement is incorrect regarding significant figures? So that means 3 statements are correct, only one of them is incorrect. So which of them is incorrect, which of them is correct, which of them is wrong? So this type of questions can be tricky and many students fall for the trap. They read the first statements, all non-zero digits are significant, this is a correct statement, they mark it and then they realize, oh, the question was about an incorrect statement. So please read the question carefully, read all the options carefully for all MCQ questions. MCQ questions are easy but because of your negligence you lose marks on MCQ questions more than anything, right? So let's see. All non-zero digits are significant. This is a correct statement, but we are supposed to find the incorrect statement. All the zeros between 2 non-zero digits are significant. This is also a correct statement. The trailing zeros in a number with decimal points are significant. This is a tricky option. So if you see, if you write a number says 15.00, then because of this decimal, these 2 zeros are also significant. That means this is also a correct statement. The power of 10 is counted while counting the number of significant figures. So if you write a number, say 3 into 10 to the power of 3, then only one significant figure is there. Power is not counted. Power of 10 to the power or even this 10 is not counted while calculating significant figures. This is the scientific notation. In scientific notation, only whatever is there on the left hand side, that is significant. So this is incorrect statement. So that means this is our correct answer. Okay. Yes, Divine Star, you are absolutely correct. Now let's move on to question number 2. The slope of the tangent drawn to the position time graph at any instant gives instantaneous velocity, instantaneous acceleration, average velocity, average speed. So let's see. So position time graph. Okay, so suppose the graph looks like this, and if you draw a tangent at any point, then this angle is theta, and the tan theta is called slope. Tan theta is called slope. Those who have studied straight line in your mathematics, they already know. If you have not, I am telling you that the m equals to tan theta, and it is given by delta y divided by delta x. So delta y is along y axis, delta x is along x axis. So in this particular case, slope is given by change in position. So here delta y itself is x, that is position. So delta y will be x and delta y will be delta t. So change in its position divided by change in time. Okay, so what is this? Is it average velocity, average speed, or instantaneous velocity? This is definitely not acceleration. It is not acceleration. Acceleration is rate of change of velocity. This is rate of change of position. So it can be either instantaneous velocity, it can be either average velocity, or it can be average speed. Which of them is correct for question number 2? Quickly. So if you see that average velocity means you have to consider the entire displacement, entire change in position, and divided by entire time. Okay, so that is average velocity. Average speed means entire displacement divided by time gives you the average speed. But this is not entire speed, this is not entire time. So that means this is an instantaneous velocity. If it is a position versus time graph, then it is instantaneous velocity. If it is distance traveled by time graph, then it will be instantaneous speed. Okay, here because it's a position time graph, position is a vector quantity, so the slope will also be a vector quantity, and that is instantaneous velocity, not average velocity, not average speed. Okay, Jafit is saying option A. Yes, you are correct. The resultant of two vectors acting at a point is minimum. So two vectors, say A and B, are acting at a point. It can be force, it can be any other type of vector. Two vectors acting at a single point. So when they will be, the magnitude will be minimum when they are acting in the same direction, perpendicular to each other, making an angle 120 degree with each other, opposite to each other. So basically you have to find the angle for which the resultant is minimum. When will the resultant be minimum? At 0 degree, at 90 degrees, at 120 degrees, or at 180 degrees. Jafita is saying option D, 180 degrees. So if two vectors are acting in the same direction, then their magnitude simply gets added, and the new vector is again in the same direction and magnitude is bigger. So basically they gets added. If this is the maximum, this will, in this case, resultant is maximum. Okay, but when they are acting in the opposite direction, okay, in this case resultant is minimum. If they are acting in the opposite direction, what happens? You need to subtract the smaller vector from the larger vector, and there's the change in their difference in their magnitude will be the resultant. Okay, and this gives you the minimum resultant value. Okay, based on this you can expect a 2-marker question as well. Okay, so this is opposite to each other, because in the opposite case the angle is 180 degrees. So there, in that case you get the minimum resultant, and in this case you get the maximum resultant. Right? Good job. Divine Star also answered. Now next question, statement 1, statement 2. Vector addition is commutative. Statement 2, two vectors may be added graphically using triangle law of vector addition. Okay, now what is the meaning of commutative? Commutative means if you are doing A plus B, or if you are doing B plus A, okay, if they are equal, then it is called commutative operation. Okay, so for one example is division is not commutative. So if you say A by B and if you say B by A, this is not equal, so that is not a commutative relation. If you change the order of two variables, then it is called a commutative relation. Okay, so for example, vectors are commutative, means if you do A plus B, then if you get B plus A, if they are same, then it is called commutative. Obviously vector addition is a commutative operator, okay, operation. Now second statement says that suppose you take A along this, B along this, okay, then the third angle will give you the addition of these two vectors. Now if you can form a triangle, it does not matter what is the order you are taking, okay, you will always get the same triangle. If the angle is same, if this angle, obviously the angle between two vectors is given for a given two vectors, obviously. So if the angle is given, no matter how you construct say A first, B first, then A, you will get the same triangle as always. The triangle should remain same. Okay, and that is the reason that vector operation is commutative. It does not matter on the order on which you have taken, it is A plus B or B plus A. Triangle will be always same. Okay, and it's a congruent triangle. So congruent triangle means third sides will be same. So because you are able to add vectors in triangle method, okay, and those triangles will be congruent, that means this third side should be same always, and that is the reason both statements are true, and statement 2 is the correct explanation for statement 1. So this kind of questions can be tricky because you might think that 1 is true, 2 is false. Actually it is not. So make sure in statement based questions you are putting an extra effort to finalize what is the correct answer. Okay, yes, Divine, you have answered correctly. Now next question. A cyclist bends while taking a turn in order to. So when you are cycling on a road, on a curved road especially, when you are taking a turn, your body automatically bends towards the curve. Why it is so? Okay, so if you are taking a turn say left-wise, your body automatically turns towards the left. Why it is so? Reduce apparent speed, reduce friction, reduce speed, provide necessary centripetal force. So Divine Star is saying option A, reduce apparent speed. Jafita is saying option D. Or Divine Star is now saying option B, reduce friction. So when you are turning, suppose this is the road, okay, when you are driving a cycle, okay, on a please pardon my drawing. So if you are driving a cycle like this, okay, what happens when you take a turn, your body automatically turns so that the component of your weight, so your weight generally acts like this. So when you are taking a turn, your body weight is acting at an angle, and because of that angle, some part of your component of your force basically provides the required centripetal force for your circular motion. Okay, so component of your body weight including your cycle's weight, that part actually provides the required centripetal force, and that centripetal force helps you to take the turn clearly, because when you are taking a turn, the motion is a circular motion, and for all type of circular motion you do need a force called centripetal force. Centripetal force cannot be is not a fundamental force, it has to be supplied by another force. It can be friction, it can be gravitational force, it can be electromagnetic force. There are many types of original forces. Those forces actually provide the required centripetal force. In this particular case, your body weight provides the required centripetal force. So that is means provide necessary centripetal force. So if you are a MotoGP fan, some of you may have seen MotoGP, while taking the turn, the MotoGP biker turns extremely flat, and almost like that they touch their knee also on the ground, and then they take the turn. Okay, that is because more bend you are doing, okay, more it is useful for you to take the turn at a very close angle. So that means your centripetal force will be provided by your body weight, your bike's weight, etc., and then you can take the turn clearly, right? Otherwise you might skid on the road. So that is a very reason that the bikers who drive MotoGP races, okay, so that is very exciting when they are taking the turn. When I was a kid, it was very exciting for me, and I was trying to understand why they bend their bodies. So now later on I realized it is because of the requirement of the centripetal force. Now, before I continue, for just one simple promotion, you have to join our WhatsApp channel to download the PDF of this lecture and all the other lectures, including me and other teachers have done. So all 1 marker, all 2, 3 marker, all 5 marker questions are already published. You can go and check that out. The PDFs are available in our WhatsApp channel. So join the WhatsApp channel. The link is given in the description section of this video. You can go and join the WhatsApp channel so that you do not miss out on the PDFs. Right? Now, let's move on. A particle made to go around a circle with a constant speed with the help of a rope. The work done by the rope. So when you have a rope, string rope, you have put some ball or some stone into that rope, and then you are rotating it. Okay, so what is the work done by the rope? Positive and non-zero, negative and non-zero, zero, none of these. Okay, so none of these is just an option, so none of these cannot be correct. So either 3 of them you have to choose. None of this cannot be an answer. Okay, so when you are rotating a stone, okay, so what is the work done by the rope on the stone? What is the work done by the rope on the stone? Option C. Yes, correct. Option C is correct, because when you are rotating a rope is in this direction and the object is rotating, suppose in a circular motion, so the motion is tangential. So the angle between the direction of motion and the force that you are applying is at 90 degrees. So this is a no work force. This is a no work force. That means work done is 0. If angle is 90 degrees, it is always no work force. That is the same reason when Earth is rotating around the sun is not doing any work on Earth, okay, because it's a no work force. Now, a question from your rotational motion chapter. Choose the correct diagram which shows the direction of angular velocity of a rotating disk. Okay, choose the correct diagram which shows the direction of angular velocity of a rotating disk. So how to find the direction of rotation? So if the object is rotating in certain direction, first you take your right hand, you curl your fingers in the direction of rotation, okay, then your thumb will point the angular velocity vector. Angular velocity is a vector. So in this particular case, the object is rotating like this in anti-clockwise direction. So only one is correct, that is if you take your fingers and if you rotate it, then only your finger is giving the correct direction, only for option C. So option C is correct for this question. Right? Yes, Jafita is correct. Again, now next question number 8. The work required to bring a particle of unit mass. The work required to bring a particle of unit mass from infinity to the given point is called gravitational potential, gravitational constant, gravitational potential energy, gravitational kinetic energy. So the work that you need to do to bring a unit positive mass, mass is always positive, unit mass from infinity to a point in gravitational field, that is called what? What is the definition? Sindhu is saying option C. Okay, can you tell me why not option A? Divine Star is also saying C. See, there is a slight difference between option A and option C. If the same question was asked, that work done to bring a particle of mass m from infinity to given point, then it would have been gravitational potential energy. But in this question it is mentioned unit mass. Unit mass, as soon as you see unit mass, then it will be not potential energy, but it will be gravitational potential. That is the definition of gravitational potential, to bring a unit mass from infinity to a point. If the mass is not given, if it is any mass, then that would be gravitational potential energy. Okay, gravitational potential energy is, say, suppose is given by u, and gravitational potential suppose is given by small u, then small u is capital U divided by mass. Okay, potential energy per unit mass is called gravitational potential energy. Gravitational potential. Okay, potential is basically for one mass, potential energy for any mass. Okay, gravitational potential energy is a general term. Gravitational potential for a given point is constant. Okay, because mass is constant. Okay, so that is the difference between potential and potential energy. If unit mass is not given, potential energy is correct. If unit mass is given, potential is correct. Okay, sorry. Yes, option A is correct. Now let's move on to the next question. So that's why I ask you to mention the question number. So if you are answering question number 9, you should answer question number 9, then ABC. Okay, just you need to type one letter extra. Okay, so that I can identify which question you are answering. Steel is preferred over copper and aluminium in structural designs. Steel is more elastic than copper and aluminium as its Young's modulus is greater than that for copper and aluminium. Among the given two statements, both statements are correct and statement 1 is correct. Statement 2 is correct explanation of 1. Both statements are correct but not correct explanation. Statement 1 is correct, statement 2 is wrong. Both statements are wrong. So from here we can see that statement 1 is at least correct. Okay, from the given option itself we see that statement 1 is correct, right? So because there is no option given here which says that statement 1 is wrong, statement 2 is correct. So either both statements are correct or statement 1 is correct. So this is a correct statement. So no doubt about it. Now we have to figure out whether statement 2 is correct or not. Okay, Javida is saying 9A. Yes. So we basically, for structural designs, when you are building bridges, house, okay, or shopping malls, everywhere we use steel rods, right? So TMT bars are basically steel rods, and those steel rods are actually structurally intact because of its high elasticity. High elasticity means it has a very high Young's modulus, so it can withstand a very large amount of force without bending or showing any deformation. Okay, so that is the main reason. So if you have a very high Young's modulus, then you can withstand a large amount of force, right, without any deformation or minimum deformation. And once the force is removed, it goes back to its original position. So that is the main reason that steel is used for all structural designs. So both statements are true, and obviously second statement is correct explanation. So option A is correct, right? Yes, both of you are correct. All three of you are correct. Now, next question. The pressure in a fluid at rest is the same as all points if they are at the same height. This is the statement of Bernoulli's principle, Pascal's law, Stokes' law, Hooke's law. So pressure is same. Suppose we have a liquid. If you go to a particular depth, the pressure is same everywhere, no matter what direction you are looking, from top, from bottom, from right, from left. Pressure is same everywhere. So whose law is this? Bernoulli's principle, Pascal's law, Stokes' law, Hooke's law. Yes, correct. So this is basically Pascal's law. Pascal's law says that any pressure is given to a liquid, it goes in every direction equally. So that is the reason when here the pressure is basically due to the weight of the liquid, and because that pressure should go in all directions equally. So that is Pascal's law. Okay, Bernoulli's principle says the pressure changes with speed. Higher the speed, lower the pressure. Stokes' law is basically the terminal velocity when an object moving through a viscous fluid, it gains a static, there is a frictional force, and that frictional force is proportional to its velocity. So that is Stokes' law. Hooke's law is from mechanical properties of solid, which says stress is proportional to strain. Okay, so these three laws are wrong. Question number 11. Two thin blankets keep more hotness than one blanket of thickness equal to these two blankets. Why so? So if you are having, say, this is currently winter, so suppose you have two thin blankets, okay, covering yourself, and this is number 1, and number 2, same thickness of this combined thickness, okay, one blanket. This one is more effective than this one. This one is more effective than this one. Why? Their surface area increases, a layer of air is formed between these two blankets, which is a bad conductor. These have more wool, they absorb more heat from outside. What is the correct reason? So if you are using a blanket right now, you will see that the blanket is basically not a very thick, but still it can maintain a high temperature because it is made up of two thin blankets. Inside there is one more layer is there. So 3-layer blankets we generally use in our day-to-day life, right? Why it is so? Ten, 11B, yes, 11B, a layer of air is formed between these blankets, which is a bad conductor. Now, question number, Ashok, please stop. Question number 12, which of the accompanying PV diagrams best represents an isothermal process? Okay, which of the accompanying PV diagram best represents isothermal process? So what is isothermal process? Isothermal process means temperature is constant. In isothermal process, temperature is constant. So what is the meaning of constant temperature? P into V, ideal gas equation, equals to mu R T. Okay, so T constant means P into V is also constant. Mu is constant for a given mole number, R is also constant, universal constant. So temperature is given constant, so PV is constant. So which of the graph represents PV equals to constant? Yes, 12B. So PV equals to constant means it's a equation of rectangular hyperbola. Okay, if you have studied hyperbola in your first PU, maybe you will study in your next class. So this is the diagram of PV equals to constant. Okay, PV equals to constant is a graph given by rectangular hyperbola. So option B is correct. Molar specific heat at a constant volume CV for a monoatomic gas is. So molar specific heat for at constant volume for a monoatomic gas is. What is the value of CV for a monoatomic gas? So let me give you a hint. CV is given by F divided by 2 into R, and Cp is given by F plus 2 by 2 into R. Okay, so these are the two relations that you should remember. So Cv equals to F by 2 into R. For a monoatomic gas means it has only one molecule. So one molecule can have how many degrees of freedom? F is degrees of freedom. F is called degrees of freedom. Degrees of freedom means how many direction it can move without having any difficulty. Okay, so generally any object have 3 degrees of freedom. Now if you add one more object to it, then based on their relative position, there can be more degrees of freedom. For example, if you add one more object to it, okay, so only one direction is restricted, both of them can move total 5 direction. So more number of molecules means more degrees of freedom, okay, but for a monoatomic gas the degrees of freedom is 3, so CV will be 3 by 2 into R. Okay, so correct answer is option A. Smitha, no, 12B. Okay, 12, you are still stuck at 12. Yes, option A is correct. Now, in simple harmonic motion, force is directed towards the opposite position, mean position, extreme position, origin position. Okay, obviously, force is directed towards the so opposite position has no meaning, origin position has no meaning, mean position or extreme position. So simple harmonic motion means suppose an object is undergoing simple harmonic motion, this is called mean position, this is the extreme position. There are two extreme positions, one is here, another one is here. So both these two positions are called extreme position and the central point is called mean position. And at mean position, if you apply a force to stop the object, it will be stopped. That is the definition of mean position. So 50-50, extreme position or mean position? Yes, 14B, mean position. Okay, because the force that is acting on a object will always act towards its mean position. Okay, so object is moving in this direction, the force will always act in the towards the mean position. That is the reason why the object always comes back towards the mean position. Velocity of a transverse wave in a stretched wire depends on tension of the wire, mass per unit length of the wire, radius of the wire, all of the above. Okay, velocity of transverse wave in a stretched wire depends on, velocity of a transverse wave in a stretched wire depends on tension, mass per unit length, radius of the wire. So this question is normally the time period of motion is given by 1 by 2L square root of T by mu. Okay, mu is the mass per unit length. Okay, T is tension here and this is time period. So both of them are T. So let me do one thing. Let me write frequency. Frequency is given by 2L square root of mu by tension T. Okay, this is the frequency. Okay, now V, velocity is frequency into lambda. So obviously it depends on length, it depends on the mass per unit length, it depends on tension, and lambda depends on the radius of the wire. So basically velocity depends all three. Velocity depends on all three of the above. Okay, so 15 D is the correct answer. Okay, now let's move on. When a body is thrown vertically upward, it will take time t to reach the highest point. Then the time taken to return to its ground. So when you are standing somewhere here, you throw a ball. So it takes a time t to reach the top position, and how much time it will take to reach the bottom. How much time it will take to reach the bottom. So if you throw something, suppose the object moves for say 1 second, then how much time it will take to reach the ground. So this is the basics of motion in one dimension. So if you move an object in upward direction, it will take the exact time to come back. Motion in 2 dimensions, sorry. So it will take the exact same amount of time to reach the ground. So the time taken will be 2t. Total time of flight will be 2t. Okay, but the time taken to reach from top to bottom will be again t. Okay, total time will be 2t, but the time taken to reach from ground to top is t, then from top to ground will also be t. Next question. A body rotates with a constant angular momentum. A body rotates with a constant angular momentum. Then torque is 0, torque is minimum, torque is maximum, torque is independent of angular momentum. Torque is independent of angular momentum. What is correct answer? So if you remember Newton's second law of motion, force acting on a body is proportional to dp by dt. In fact, it can be shown force acting on a body is equals to dp by dt. dp by dt means rate of change of momentum. Force equals to rate of change of momentum. Proportionality constant is 1. Now this is a linear motion. Torque acts in a rotational motion, and the equivalent of force is torque, and equivalent of linear momentum is angular momentum. So torque depends on the variation of angular momentum. Okay, so dl by dt, don't be afraid. I hope you have already done differentiation in your mathematics class, basic differentiation, so you are aware of differentiation. When you started this chapter at the beginning, in your first year beginning, physics teacher was teaching a lot of differentiation, integration. You are thinking, what is this, how can I pass in physics? And from there on, physics fear started on. But now you are already have done differentiation, integration. You will learn in your next class in mathematics. Okay, physics teachers already have taught you, but you will learn more about it in your next class. Anyway, so differentiation means what? If you are doing a differentiation of a constant quantity, then that should give you 0. So if the angular momentum is constant, then L is constant. So when you are differentiating a constant quantity, you should always get 0. That means torque is 0. Okay, torque is 0. Now let's move on to the next question. What is the value of universal gravitational constant in SI units? Now you might feel that this is an easy question, but this question was given in, I think, 2 years back, when board was still making the final paper, and this question was given, and trust me, many students answered it wrong. Okay, so options are slightly different, I know, but many students answered that wrong because of the unit. Okay, Newton meter square per kg square is the unit of gravitational constant. Okay, so, and the correct value is 6.67 into 10 to the power of minus 11. So there was one more option, 6.67 into 10 to the power of say 7 or plus 11, and the unit was given something else. So you have to careful about Newton meter square per kg square, and it is 6.67 into 10 to the power of minus 11. Now let's move on to the next question. The maximum load a wire can withstand without breaking when its length is cut into half of its original length will be. Okay, so suppose we have a wire. It can withstand a force of F. It can withstand a force of F before breaking. This is the breaking point. Now if you cut the wire into half, then what will be this force? Breaking force. Okay, now breaking force does not depend on length, it depends on area of the wire. Okay, so more the area of the wire, breaking force will be breaking force required to break the wire will be more. So breaking force is independent of the length. So even if you cut the wire into half, the breaking force should remain same. The breaking force does not depend on length. Okay, even if you cut the wire, you will still need the same amount of force. Okay, because the surface area or the radius of the wire remains same. So because of that fact, the breaking force should be same. Question number 20. In the relation mu equals to PV by RT, mu is number of molecules, atomic number, mass number, number of moles. So the relation mu equals to PV by RT, it is the number of moles. D is number of moles. Now we will move on to our 2-3 marker questions. So all the MCQs are done. Now we will be solving 2-3 marker questions. All the 2-3 marker questions I am discussing today are very, very, very important. Give any two limitations of dimensional method. So dimensional method, there are a few limitations. it cannot determine the values of numerical or dimensionless constants in equations. For example, numbers such as half, pi or exponential e that appear in many physical formulas cannot be found using dimensional analysis. So for example, time frequency of wave in a stress string is given by 2L square root of mu by t. Now obviously you can find L, you can find mu, you can find t, but these two cannot be calculated. Okay, so that means this two is beyond the scope of the dimensional method. Okay, so dimensional method, even they are handy, you cannot find some constant involved in the dimensional in the formula. It cannot be applied to formulas containing trigonometric, exponential or logarithmic functions. This method only works for equations that are algebraic and consists of products of ratios of power of quantities with dimensions. Okay, for example, in simple harmonic motion, x equals to a sine omega t plus phi. This equation you cannot prove or derive using dimensional method. Okay, dimensional method will only give you x equals to a, but this sine omega t plus phi, this sine omega t related terms cannot be calculated using dimensional method. Similarly, work done in isothermal process, W is equal to ln V final minus V initial. This formula can also not be derived using a dimensional method. Okay, so these are the equations which cannot be determined using dimensional method. Now next, write any 2 or 3 rules for writing significant figures. 2 rules, 2 marks, 3 rules, 3 marks. All non-zero digits are significant. For example, in the number 456, all 3 digits 4, 5 and 6 are significant. Zeros between non-zero digits are significant. Okay, for example, in 4005, all 4 digits 4, 0, 0 and 5 are significant. Trailing zeros in a number with the decimal points are significant. For example, 50.00 has 4 significant figures. Now in some cases there might be a small 2 mark or 3 mark numericals where they will give you some numbers and they will ask you find the exact significant figures. Okay, and that can be found using these 3 rules. There is 2 more rules, but I am not discussing that. Mostly you will find something which is similar to this, and if you are find something like say 5000, then these zeros are not significant. Okay, if there is a decimal, but if you put a decimal, then not only these 3 zeros, these 2 zeros are also significant. Okay, so decimal means all zeros are significant. Okay, no matter where they are. If there is no decimal, then the last zeros are not significant. Okay, now next, let's move on to the next question. Draw the position time graph for a body moving in positive direction with negative acceleration, positive acceleration, constant speed. So this is the negative acceleration graph, this is positive acceleration graph, this is constant speed. So in negative acceleration, the position slowly decreases. In positive acceleration graph, the position slowly increases. If the speed is constant, the line is a straight line. This is accelerated motion. In accelerated motion, position time graphs will always be curved graphs. In constant speed, it will be a straight line. Okay, this is also very common and most asked question. 2 vectors of same units have magnitude 9 and 5 units. What are the maximum and minimum magnitude of the resultant that can be obtained from these 2 vectors? So maximum, obviously I told you, maximum resultant is 9 plus 5, that is 14 units, and minimum is 9 plus 5, that is 9 not plus, 9 minus 5 equals to 4 units. Okay, mention any 2 properties of elastic collision. In elastic collision, not inelastic, in elastic collision, total momentum of the system before and after the collision remains constant. The kinetic energy before and after the collision remains same. Okay, so in elastic collision, momentum same, kinetic energy same. In inelastic collision, momentum same, kinetic energy different. Okay, so be aware of that. I am giving you elastic means in the exams, suppose they are giving you inelastic, then you are saying, sir, you told us elastic, but in the exam inelastic was asked. So in elastic case, kinetic energy is not constant, momentum is still constant, right? State and explain work energy theorem for a constant force. The work done by a constant force on an object is equal to the change in its kinetic energy. So if you are doing work on a applying constant force, work is given by Kf minus Ki. Ki is initial kinetic energy, Kf is final kinetic energy. What is a Carnot engine? Name the working substance used in it. A Carnot engine is a specialized or idealized heat engine that operates on the Carnot cycle and is most efficient engine possible under the law of thermodynamics. It consists of 4 reversible processes, 2 isothermal constant temperature and 2 adiabatic no heat exchange processes. So if you draw the diagram, the graph looks like this. Okay, this is these two are adiabatic process, isothermal processes, and these two are adiabatic processes. And why it is called a cycle? Because it closes, its starting point and ending point are same. That's why it is called a cycle. Okay, so this is a general diagram of Carnot's cycle. Working substance of Carnot cycle is ideal gas. Now all the engines that we use in our day-to-day life are not as efficient as Carnot cycle. So if you give the same condition of our working principle to a Carnot engine will be more efficient than any other engine possible. Okay, this is an ideal engine. Carnot engine is an ideal engine, and even Carnot engine does not have an efficiency equal to 100%. So any engine that we operate in our day-to-day life, they will never be able to have 100% efficiency. State and explain first law of thermodynamics. Statement: when heat capital Q is supplied to a system, part of it increases the internal energy delta U and rest is used to do work W on the surrounding. So delta Q is equals to delta U plus delta W. This law is basically the law of conservation of energy applied to thermodynamic system. It states that energy cannot be created or destroyed, only transferred or converted from one form to another. Hello Guru, how are you? Give the positions at which the potential energy of a particle executing SHM will be maximum and 0. Okay, give the positions at which the potential energy of a particle executing SHM will be maximum and 0. So where it will be maximum? It will be maximum at extreme positions. Okay, potential energy is maximum at extreme positions and potential energy is minimum at mean position. Okay, similarly, if the same question is asked about kinetic energy max at mean position. That is x equals to 0, and kinetic energy is minimum at extreme position. That is x equals to plus or minus amplitude A. Okay, so you should remember not only potential but also you have to remember the kinetic energy as well. State and explain Newton's second law of motion. Define SI units of force. The rate of change of momentum for a body is directly proportional to the applied force and occurs in the direction of the applied force. Mathematically, father equals to ma. Okay, F equals to ma. Where force is applied, m is mass of the object, a is acceleration of the object. SI unit of force is the Newton. Definition: 1 Newton is the force required to accelerate 1 kg of mass by 1 meter per second square. So if you put F equals to 1, M equals to 1, A equals to 1, then you get the value where if for 1 kg mass, if the acceleration is 1 meter per second square, then the corresponding force is called 1 Newton. What is meant by range of a projectile? Give the expression for the same. What is the angle of projection for which the range of a projectile is maximum? The range R of a projectile is the horizontal distance it covers from the point of projection to the point where it lands on the same horizontal level. R is given by u square sine 2 theta by g. The range is maximum for theta equals to 45 degrees. Define Young's modulus, rigidity modulus and bulk modulus. These three definitions are very important. Young modulus is longitudinal stress by longitudinal strain, rigidity modulus is shear stress by shear strain, and bulk modulus is pressure or volume strain divided by volumetric volume stress divided by volume strain. So all these are ratio of stress by strain. Okay, stress means force per area. Okay, here it is also shear force per area, and for volume it will be pressure itself. Okay, again force per area is actually pressure, but for liquids it directly is the pressure. For solids and this is also solid, for solids it's stress, for liquid it is pressure. So this is very easy, just remember these three formulas. Definition is basically you have to write the same thing. Okay, ratio of longitudinal stress by longitudinal strain, then you write this. Okay, do not write the formulas only, then you will be losing marks for writing wrong answer, incomplete answer, not wrong, incomplete answer. Mention any three methods of reducing friction. Very, very important question. Lubrication, applying lubricants like oil, grease to reduce friction. Polishing the surfaces, making surfaces smoother by polishing. Using ball bearing, replacing sliding friction with rolling friction by using ball bearing can also reduce friction. So these are the three processes to reduce friction. Mention any three advantages of friction. Helps in movement. Okay, friction helps in stopping, enables gripping and holding of objects. Okay, so these are the 3 points where friction is advantageous. If there is no friction, I would not be able to write on the board, I will not be able to walk on the street, neither be you. Okay, so everything would have been impossible. So friction is, that's why it is called, friction is a necessary evil. Okay, because obviously friction is not desired completely, because it reduces the life longevity or life of some certain objects, but still it is a necessary evil because it is still required for us to walk, to ride, okay, to hold something. So that is why friction is also required. Friction is not required because if you are using, for example, if you are driving a car, after some time the brakes are gone, the wheels, the ball bearing used inside the wheel, they are also gone. You need to change the ball bearing, you need to change the brake pads, etc. Okay, and that is basically it is, that's why it is evil, but also it is helpful for us because it is it required certain works we will not be able to perform without it. Distinguish between longitudinal and transverse wave. Longitudinal waves, particles of the medium vibrate parallel to the direction of wave. So particles vibrate parallel to the direction of wave. Okay. Transverse wave, particles vibrate perpendicular to the direction of wave. So particles vibrate in the direction perpendicular to the wave. Okay. Consists of compressions and rarefactions, consists of crests and troughs. Okay. Example, sound waves in air. Example, any light waves or waves, stretched string, water waves, etc. Okay. Derive the expression v square t vt x equals to vt plus at square, ut plus at square or v naught t plus at square. Now first of all you have to draw the graph. So what is the graph? The graph looks like this. So what is this graph represents? Which college are you guys from? Noot. These students are from all across Karnataka. They are, I'm not sure which colleges they are from, but anyway, mention which college you are from. Okay, so if you are asking someone, you have to mention your college name as well, right? It is a common courtesy. So now, suppose an object is moving starting with a constant velocity, initial velocity, and then it starts to accelerate. Okay, so initial velocity represented by this this distance. This is the distance of initial velocity. Initial velocity means this is the velocity axis, this is the time axis. So initially at time t equals to 0, the velocity was not 0, but it has a fixed value, say 2 meters per second square. Suddenly it started to accelerate, and when it starts to accelerate, its velocity kept on increasing. Acceleration is constant, that's why velocity time graph is a straight line. Okay, now you have to find the expression x equals to vt plus there is one small mistake, it will be half at square. Okay, ut plus half at square. So basically, in other sense, what we are deriving s is equal to ut plus half at square. Same equation. Okay, same equation, but generally in our colleges and some teachers like to use this form, but this form is given in your textbook, that's why I am using the textbook form. Okay, no difference between them. Only thing you have to remember, if the question is asking you about u, then it will be u. If they are asking about v naught, then it will be v naught. Okay, whatever form they have asked, you have to use that. Hi Sridhar, how are you? So now what? Now you have to find the slope of this line. This is very, very important. The slope of this line is very, very important. So what is the slope of this line? How to calculate slope? Slope is, as I mentioned, slope is given by delta y by delta x. Okay, so if you see here, slope of this line actually will give you, because it's a velocity time graph, slope of this line will give you the acceleration. Slope of a velocity time graph gives you acceleration. So acceleration is given by delta y is v minus v naught. V is the velocity after some time. V is the velocity after some time t. So v minus v naught is delta y, and what is delta x? Delta x is the entire time t. So this is, so from here we say at equals to v minus v naught, or v equals to v naught plus at. Okay, this is the slope. Some students don't mention it, you have to mention that from the slope of the graph we get v is equal to v naught plus at. Next part is in the area under velocity time graph. Area under velocity time graph gives the displacement. Area under the velocity time graph gives the displacement x. Okay, area under the velocity time graph gives the displacement x. So from here we can say x equals to area under the graph. Area under the graph means you have to consider the area of this triangle and area of this rectangle. So AODC rectangle, AODC plus triangle ABC. Okay, so what is area AODC? AODC is this rectangle, so it is length into breadth. Now length is time t, breadth is v naught, so it will be simply v naught into t plus what is the area of ABC? Area of ABC is base into height, half into base into height. Half, what is base? Base is time t, and what is height? Height is V minus V naught. Okay, V minus V naught. So if you see in this equation, V minus V naught is equals to AT. So you just need to put that V naught T plus half T into AT. You mark this equation as equation number 1. So from 1. Okay, so you get V naught T plus half AT square. So x equals to V naught plus half AT square. So this is the derivation, easy derivation, but this is a very common and most important derivation of your PU1. State the law of conservation of momentum. Prove the law of conservation of linear momentum using Newton's laws of motion. So what is the law? The total linear momentum of an isolated system remains constant if no external force acts on it. So basically it states that if you have two objects, say object A and object B, and no external force acts on them, then the total linear momentum of this system will be constant. So we have to show that. Suppose mass of A is ma, mass of B is mb. Initially A was moving with the velocity ua towards B and B was moving with the velocity ub towards A. Now what will happen? No external forces acting on this system. They are already initially they are moving. So when they are moving towards each other, then they will collide. So when they are colliding, at the moment when they are in contact, say they are in contact for say a time t. They are in contact for say a time t. Okay. So A will apply a force on B and B will apply a force on A. Okay, during the contact time. Okay, and according to Newton's third law of motion, FA must be equals to FB. Right, equal and opposite reaction. Negative sign represents opposite. Okay, and the equal sign represents they must be equal in value. So equal and opposite reaction will act on the object and then they will separate. So once they are separated, now A is moving with a new velocity, say VA, okay, and B is also moving with a new velocity VB. Okay, so their velocity is now changed. Now we have to show that the total initial momentum was what? Total initial momentum was MAUA plus MB UB. Okay, and the total final momentum MA VA plus MB VB, these two must be equal. That is our objective to prove. So how to do that? So we will start with our Newton's third law. From third law, we can write FA equals to minus FB. Now from second law, force is given by change in momentum divided by the time. Okay, rate of change of momentum. So change in momentum divided by time is the force, right? Now what is the force exerted by A? So FA must be equals to its change in momentum. Initial momentum of A was MAUA and final momentum is MAVA. So change in momentum is final momentum minus initial momentum. Okay, and divided by the time of contact. Okay, time of contact say is given by T. Now what about FB? FB again the same formula, change in momentum. What is change in momentum? MB VB, final minus initial. Always remember final minus initial. divided by t. So suppose in your first unit test you scored 0, now in your annual test you score 100, then it will be 100 minus 0. Okay, that is 100. Okay, so that is always the case. So if you are improving, that is a good sign. Now final minus initial, in between values does not matter. Now what? So as I mentioned, FA must be equals to minus FB. So you just need to put these equations back to equation number 1. Okay, so let's substitute MAVA minus MAVB. Sorry, not MAVB, MAVA. Let me erase this. MAVA. So both, for A everything is A, for B everything is B. Okay, for B everything is B. Divided by time of contact T equals to MB VB minus MB UB divided by time T. Same time of contact, so time of contact can be cancelled, and there is a negative sign because it is from Newton's third law. Now let's rearrange. MA VA minus MA UA equals to minus MB VB plus MB UB. Okay, minus sign you have multiplied, so this becomes negative, this becomes positive. Now all V terms in the same side, so MA VA plus MB VB equals to all A on the other side, MA UA plus MB UB. Now what is this? This is the final total momentum. So total final momentum equals to total initial momentum. So momentum of the object at the beginning is equals to object at the last. Pascal's law badalla. Pascal's law, don't worry. Pascal's law, if you don't know Pascal's law, either you there is one MCQ I have done. Okay, I have done one MCQ that is based on Pascal's law. Otherwise, the pressure applied to a liquid at any point transmits in all direction equally. That is Pascal's law. Okay, based on Pascal's law, there will be, even if there is a derivation, you can skip that, because other derivations that I am doing right now, you can answer, right? Gokarna Suresh. Are you from Gokarna? Very beautiful place. 38. Show that the trajectory of a projectile is a parabola. This is one of the most important question. Okay, this is one of the most important questions and very common as well. So here we have projectile motion. Object is projected with a velocity v. Okay, and when you are projecting the object with a velocity v, it will move in such a fashion. The angle of projection, say theta. Then what you have to do, you have to find that you have to show that this motion actually represents a parabola. How to do that? For that you have to take an arbitrary point, say point P, and its coordinate is x comma y. Its coordinate is x comma y, right? And you have to show that if you try to find the path tracked by x and y, it is the equation of a parabola. Now obviously what else you have to do? You have to take the x and y component. So x component is given by, x component is adjacent to the angle theta. X component, let me use a separate color. Let me use this one. So x component is along the angle theta, so it will be v cos theta, and this is the perpendicular component to the angle theta, so it will be v sin theta. Okay, now if you see at this point x and y, this is x and this is y. So y coordinate is this one, x coordinate is this one. Okay, now if you remember that when an object is moving in a projectile motion, there is a gravitational acceleration acting vertically downward. Okay, the gravitational acceleration is acting vertically downward. Okay, so when you are applying a force and the object is moving in the vertical motion, so first of all, why did we separated these two motions? So that I can apply the law of motion individually. So whatever is that motion along y-axis is independent of the motion along x-axis. Okay, x and y are independent of each other. So motion along y-axis, let us start with motion, or motion in x-axis is easy. So motion along x-axis. Suppose the object reaches to point P at a time t. After time t, the object reaches to the point P. So what is the displacement in the x direction? Displacement in the x direction, that is x, is given by the speed along x direction into time. Okay, s equals to vt, right? S equals to vt, displacement. Now there is no acceleration in x direction, so simple vt not half at square. Half at square, a is 0. So x equals to v cos theta into time t. Now time t is something that we are not interested in, so we will simply find time t and we will replace it later on. So time t is equal to x by v cos theta. Okay, x by v cos theta. Now motion along y-axis is next. Motion along y-axis. Now how to find that? So motion along y-axis means velocity is given v sin theta, there is a gravitational acceleration acting in the opposite direction. So y will be equals to vyt minus half gt square. Y minus because velocity is upward direction, gravitational acceleration is downward direction. So they are opposite, that means there will be a negative sign. So now we will try to find y. Y equals to v sin theta into t minus half gt square. Okay, now t value we have calculated in this equation, so we just need to take this t and substitute in this equation. So y equals to v sin theta into x by v cos theta minus half g x square by v square cos square theta. Okay, t square is there, so that means square of this term, and we have substitute. So this equation here, in this particular type of equation, t is called parameter. Okay, and our only target is to remove or eliminate the parameter. So if you see this equation, t is removed, so this is a parameter free equation. So remember the steps are same. So y equals to tan theta into x, y equals to tan theta into x minus half g divided by v square cos square theta into x square. Okay, so this is the equation. Now if we write this equation, y equals to ax plus bx square, where a equals to tan theta, b equals to minus half g divided by v square cos square theta. This is a generalized equation of a parabola. This is a generalized equation of a parabola. Okay, this is a parabola. Now if you see that in this equation we have ignored the friction due to air, so without considering friction due to air, the motion of a projectile motion is a parabola. So this is the trajectory of a parabola. So this is the derivation. Now derivation, the steps are very clear. First of all, you have to draw the diagram, v cos theta, v sin theta, take a point P after time t, the point, suppose the object reached to a point P of coordinate x and y, then distance travel along x direction is x, distance travel along y direction is y. Now motion along x-axis is given by x equals to vxt. Solve it, find t, name it equation number 1. Then motion along y-axis, calculate y, and then just you need to substitute this t in this equation. So once you substitute everything, simplify it, very easy, and you will reach this ax plus bx square. This is a generalized equation of parabola, so the trajectory of a projectile motion is a parabola. This is the most common derivation and important derivation. Derive the expression for acceleration due to gravity at a point below the surface of the earth. Above the surface of the earth I have done in all my derivation, you can go and check that out. This one also I have done, but this one is more important than acceleration on the top. Okay, so basically if you go to a depth d inside the earth, the gravitational acceleration is obviously not same on the surface. Suppose a mining team is doing mining inside, so what will be the gravitational acceleration there? The radius of the earth is given by r, the mass of the earth is given by m. Okay, this distance will be given by r minus d. Okay, so the inner sphere is given by a radius of r minus d. Now one very important part is that here we assume that the mass density of earth is constant. Mass density rho, mass density means mass divided by volume. Okay, mass divided by volume rho is constant. So rho is given by mass of earth divided by volume of earth. That is, mass of earth can be given by density into volume. So what is the volume of earth? If you consider earth to be a sphere, then volume is given by 4/3 pi r cube, right? So this is the mass of earth in terms of density. Now the important part is that when you are trying to find gravitational acceleration inside the earth, okay, then only mass that you need to consider is the mass which is there, okay, mass which is enclosed by the sphere of radius r minus d. Okay, outer mass does not contribute towards the gravitational acceleration. So it does not give any contribution for gravitational acceleration. Suppose the gravitational acceleration in here is given by g dash, then g dash, any mass which is outside this zone will not play any role. So they are independent. So only you need to calculate the mass enclosed by radius r minus d. So from there, from using the same concept, we can say m dash is given by rho 4/3, rho is constant, 4/3 pi r minus d whole cube. So this is the m dash. Now what? So we have to find the ratio of m by m dash, which will come out to be very simple. Everything will cancel. Only r cube divided by r minus d whole cube will be left. Okay, so this is the ratio of their mass. Now what is gravitational acceleration on surface? Gravitational acceleration on the surface is gm by r square. Gravitational acceleration on the surface is gm by r square. Similarly, gravitational acceleration at a distance r minus d inside the earth will be given by gm dash by r minus d whole square. Okay, now if you take the ratio of these two, g dash by g equals to g dash by g equals to m dash by m into r square by r minus d whole square. Okay, so we have calculated m by m dash, so m dash by m will be reverse of that, r minus d whole cube by r cube. Okay, now put that value in this equation. So we get r minus d whole cube by r cube into r square by r minus d whole square. Okay, so r square cancelled, r cube, this cancelled, and you get r minus d by r, or 1 minus d by r. So g dash equals to g into 1 minus d by r. Okay, 1 minus d by r. At the center of the earth, d is equals to r. So at the center, r by r is 1. So 1 minus 1 is 0. Okay, at the center of the earth, gravitational acceleration will be 0. This is the shortest, easiest derivation. If you start from here, then if you put all these values here, then if you take the ratio, then it will be massive long, and there is a chance that you make mistakes. So calculate the masses first, find the ratio of the masses, and then you calculate the gravitational accelerations using the basic formulas, and then you take their ratio. So it will only turn out to be the ratio of masses and this radiuses. So you don't need to put these masses in this equation and then take the ratio. That will be a hugely complicated, difficult process. So first take the masses, find their ratio, which is very simple to find, and then use that ratio to calculate the ratio of the gravitational accelerations. And this is the shortest and easiest way to find this answer. Right? Next, using first law of thermodynamics, arrive at the relation Cp minus Cv equals to R. This is also very common and important derivation. So first law of thermodynamics, dq equals to du plus dw. This is first law. Also we know that dw is given by p dv. Okay, for an ideal gas. So dq can be written as du plus p dv. Okay, now what? What is Cp? Cp is given by dq by dt at constant pressure, and Cv is given by dq by dt at constant volume. Okay, so first we will try to calculate Cp, and then we will try to calculate Cv, and then we will try to find their differences. Okay, Cp. So just put dq, the value of this, so we get Cp equals to du plus p dv divided by dt. Dt is the temperature, by p. Okay, so just try to understand the first law. This is the definition, and this is a differentiation. Treat this as differentiation. Once you start treating this as differentiation, 90% of your life doubt will be solved. So you will get du by dt. Now du and dt are dependent, but it does not depend on pressure or volume. So you just simply write du by dt. No need to write any suffix p over here. This p represents constant pressure. So constant pressure, U depends only on temperature, U is independent of pressure or volume. So simply they will be separated. Plus, now pressure is constant, so no differentiation of this pressure, and we get dV by dt. dV by dt. So what is dV by dt? How to calculate that dV by dt? PV equals to RT for 1 mole gas. Because we are proving Cp minus Cv equals to R, that is gas mole number is 1. So from here we get V equals to RT by P, or dV by dt at constant pressure. Pressure is constant, R is constant, so dt by dt is 1. Okay, dx by dx, ddx of x, which is 1. So that means this value turns out to be simple R by P. So we get du by dt plus P into R by P. So P cancels and you get du by dt into R plus R. So we have calculated Cp. Now we have to calculate Cv. What is Cv? Cv is constant volume. Constant volume means dV equals to 0. At constant volume, dV equals to 0. Right? So Cp is simply du by dt. Cv is simply du by dt. Why? dq by dt out of constant volume means dV 0. So dV 0 means only du is left. So whatever heat you are supplying, that is going to change its internal energy. So and internal energy depends only on temperature. So this is also independent. Okay. So from here we get Cv is equal to du by dt. Now Cp minus Cv is equal to du by dt plus R minus du by dt. Obviously du by dt cancels and you get Cp minus Cv equals to R. Simple derivation if you use differential method. If you use differential method, this is very simple. If you are not using differential method, it can be tricky and it can be long as well. Next, write Newton's formula for speed of sound in air. Explain why and how Laplace modified Newton's formula of speed of sound. Newton's assumed that sound wave travel in an isothermal condition at constant temperature. So speed of sound was given by P by rho, but that value turned out to be around 280 meter per second. Okay, which is very far away from actual value of speed of sound, which was 332 meter per second. So here V is speed of sound, P is atmospheric pressure and rho is density of air. Okay, according to Laplace, sound wave compresses and expands in air rapidly, meaning that heat exchange does not have enough time to occur. So one thing you have to mention, V measured equals to 332 meter per second. So there is almost 52 meter per second difference, which is huge. If it is 5, 6 or 10, still acceptable, but because the difference is huge, almost about 332 meter per second, 52 meter per second, that is not acceptable. According to Laplace, sound waves compress and expand in air rapidly, meaning that heat exchange does not have enough time to occur. Instead, an isothermal process, the sound wave propagate follows the adiabatic process, that is no heat is exchanged. So instead of isothermal, adiabatic process is correct, and in adiabatic process PV is not constant, PV to the power gamma equals to constant. So if you substitute that, you will get speed of sound in air is given by gamma P by rho, and this turns out to be very close to 340 meter per second, which is very close to our measured value. Okay, that is why Laplace's equation is considered to be more correct than Newton's formula. So there is at least one place where Newton was not correct. Okay, Newton says isothermal, but Laplace said adiabatic, and he corrected Newton's formula and he showed that this is the more correct value than Newton's formula. State and prove work energy theorem for a variable force. This can be tricky if you are not very good with calculus. For a variable force means the force is not constant. For a constant force, the derivation is simple, that is a 2 marker or maximum 3 marker question. You have to start with v square minus u square equals to 2as, and then you have to multiply with half and mass. So half mv square minus half mu square equals to mas. Okay, now ma means F into S, that is work done. So this is the formula, this is the derivation of work energy theorem for constant force. Okay, so constant force means m into a is constant. So this is the equation of motion, v square is equal to u square plus 2as. So you just take that equation in like this, v square minus u square equals to 2as. Take this 2 in the division on this side, multiply everything by m, and then you get this equation. So this is the very simple and easy derivation. But variable force is a 5-mark question, and for that you need to know the differentiation method. So where we will start? We will say that we applied a small amount of force at some instant small f, and the displacement of the object is given by dx. If the work done is at this point is dw, then dw equals to f into dx. Now for a small duration, for small distance dx, f can be assumed constant, so work done can be calculated using this. Now what is work done? So what is force? Force is given by obviously mass into acceleration. Now obviously acceleration is not constant because force is variable, mass is constant, acceleration is not. So what is acceleration? Acceleration is rate of change of velocity. Acceleration is rate of change of velocity. Rate of change of velocity means dv by dt. So what you have to do, you have to take this definition of force over here. So mass dv by dt into dx. Why we are using differential? Because force is not constant. That is a major thing. So from here we can say m dv dx by dt. So what we have done, we have shifted this dt onto the second term. Now what is this? Rate of change of displacement. Rate of change of displacement means velocity. So mv dv. So this is the small work done. mv dv is the small work done. Now if you calculate the small work done, then you can calculate the total work done. Total work done is integration of dw starting from 0 to w, and that is equals to integration of this thing starting from v initial to v final. Now obviously integration you are not you may not have studied outside physics, so that can be slightly tricky, but this integration is easy. Mass is constant, so similar to differentiation, any integration as well, the constant goes out of the integration, so you are left with v dv. You are left with v dv. So mass into v dv means it is similar integration of x dx, which gives you x square by 2. So here you get v square by 2 v initial into v final, okay, or m by 2. So integration, this is a particular type of integration which is called definite integration. So once the integration is done, you have to substitute this constant, this variable, with first upper limit. So just v square will be vf square minus this same v square will be now vi square. Okay, so this is the way to solve a definite integration. So definite integration means first you have to put the upper limit, next you have to put the lower limit, same value. Half is a constant, that's why it is out. So we get here half m vf square minus half m vi square. So now remove the bracket. So what is half m vf square? It is the final kinetic energy. It is the final kinetic energy, and this is the initial kinetic energy. So work done is basically difference in kinetic energy, even if the force is variable. Even if the force is variable, the work done is just the difference of kinetic energy, and this is the work energy theorem. Okay, so this is the derivation of work energy theorem for variable force. This is the 5-mark derivation. Okay, so this is the end of today's lecture. If you have any doubts, any questions, don't forget to mention in the comment section below, and obviously I'll be back with more questions in future. So I will see you in our future lecture, and obviously if you want to download today's PDF, don't forget to join the WhatsApp channel and subscribe to our channel for more videos on your PU1 and upcoming PU2 class once you get promoted, right? Till then, bye.